In this video, I'll be going over the sigfigs worksheet. But before I do that, I want to look back at some key points from our notes. The first thing is looking at these three different types of zeros. There are leading zeros, which are up in front of a number, trailing zeros, which come at the end, and sandwich zeros. All right? When we're deciding whether or not a significant figure is important, we have to look at what kind of zero it is. I'll say everything that's not a zero is no matter what important. We wouldn't write a 4 if we didn't know it was a 4, or a 2 if we didn't know it was a 2. So when we're deciding what sorts of things are insignificant, zeros are the only thing that it's really questionable about. And so we look at the leading zeros and the trailing zeros without decimal points, which I'll talk about here on this next slide. And those are the only two things that are not significant, all right? Leading zeros are never significant. Those are always just placeholders. Trailing zeros, those are placeholders if there's no decimal point, but if there is a decimal point there, that says the trailing zeros matter. So keep that in mind. And then again, here in scientific notation, we don't count the times 10 to the power, okay? So keep that in mind. Two different things that don't matter. Leading zeros never matter for significant figures, and trailing zeros without decimal points don't matter. Because that will be a big thing in what we're talking about here in this worksheet. The other thing I want to review is the two different rules that we have when we're doing math with significant figures. So we have one that's called the addition-subtraction rule. It makes sense that we're going to use that whenever we're doing addition or subtraction problems. The way this works is we count the decimal places. And when I say decimal places, I mean like hundreds, tens, ones, tenths, hundredths, thousands. Okay, we see how precise the number is in terms of decimal places, and we go with the least precise of those decimal places. So for example, in this one that I have here, it went out to 3 decimal places to the thousandth place, and then the second number went out to 2 decimal places, and so our answer needed to go out to 2 decimal places. You go with whatever of those is least precise. The other rule that we have here is called the multiplication-division rule, and again, as the name says, you'll use it whenever you do multiplication and division. For that, we're counting sigfigs. All right, so in the examples here, we've got 10.0, which has 3 sigfigs, divided by 2.5, which has 2 sigfigs. Comparing 3 and 2, 2 is the smaller number, so our answer should just have 2 sigfigs. All right, so as we're going through the math, it's important that you keep these rules straight and know which one we're dealing with at a given time, because otherwise you can end up with the wrong answer on a problem. Jumping back to the worksheet here, I'm going to go through each of these problems and explain how it's done. The first section here, we just have to count the number of sigfigs. And so really what we're doing here is we're looking at zeros and deciding whether the zero matters or whether the zero doesn't matter. Anything that's not a zero is always a sigfig. Okay, so for instance, in problem number 1, we look at this zero here. That zero is in the middle of some other zeros, and that makes it what we call a sandwich zero, which means that it does matter. All right, if that zero matters, then we have 3 non-zeros and the zero that doesn't matter, so everything, the zero that does matter, so everything in this number matters, so all 4 of those digits are significant, and we say 4. Problem number 2, none of those are zeros, so they all matter, so we have 3 significant figures. Problem number 3, this is another sandwich zero. It's in the middle of other zeros, so sandwich zeros always matter, so this one has 4 sigfigs. Number 4, all right, now we have 2 different kinds of zeros. We've got these ones which are up front. Those are leading zeros. Leading zeros never count, all right? Then we have this zero here, which is a sandwich zero, which does count. Okay, getting rid of the leading zeros, which don't count, we have 4 digits left, which are significant, so that's 4 for this one. On number 5, it's in scientific notation. Remember, with scientific notation, we ignore what comes after the times 10 to the power, so we're just looking here. 4.6, that's 2. For number 6 here, again, it's scientific notation, so we ignore what comes here at the end. That's just telling you where to move the decimal place. So 4.06, this zero is a sandwich zero, which means it does matter, so we've got 3 numbers that matter in this one, 3 significant figures. On to number 7. This is 750. This zero here is a trailing zero. Trailing zeros are the trickiest ones because they might matter, they might not. What you do is you look for a decimal point. There's no decimal point on this one, which means that it doesn't matter. Okay, so that's not a significant 0, which means we only have 2 significant digits here, the 7 and the 5. Oops, that's 2. 2 significant figures. Number 8, 75, those are both non-zeros, so they count for sure, so that's 2. 75,000, trailing zeros again, no decimal point. Those zeros don't matter, so we're just left here with 2 significant figures in the end, so that's 2. 75.00, all right. Here these are trailing zeros, but there is a decimal point, so they do count, all right. So the 7, the 5, the first 0, second 0, that's 4. All right. Next one. This one is 75,000.0. These are all trailing zeros. There is a decimal point in this number, though, so all the trailing zeros count. So that's the 4 zeros, the 7, and the 5, which makes 6 significant figures. And then number 12 here, 10, that's a trailing 0. There's no decimal point here, so the trailing 0 doesn't matter, which means we only have the 1 in this case. So there's only 1 significant figure. All right, for this next step, we are rounding. What you do when you round is you always start on the left side of the number and go right until you have what you need. So we're going to start on the left. We're going to go right here until we have 4 significant figures. I stop there because 3, 6, 8, 2, those are all significant. And then I look at the one that comes after that, and it's a 4, okay, which means I round down. So 3.682 is what we end up with there. Similarly here, we're going to start rounding to 4 significant figures. We're going to go over until we get 4 numbers that are significant. All right. And then we look here. What we have is a 0 after that, so we'll round down again. So 21.86 is the answer there. $375.6523, starting here, we go over until we get 4 numbers. Then we cut it off. We look at that 5 there on the other end. 5 and up, we're going to round up. So this ends up 375.7. For the next one, 112.5. All right. This one, we got our 4. That's a 1 after that, so it runs down. 112.5 is what we end up with. And then for the last one here, 45.4673, we go until we have 4, then we cut it off. We look, there's a 7 after that, so we're going to round up, so it's 45.47. Continuing on, in this next one I'm rounding it to 1 decimal place, okay, to the 10th place is what that means. So we go over until we get to the 10th place, and we cut it off. That's a 5 after that, so we'll round up, so that makes this 1.4. All right. On to the next one. Again, rounding to 1 decimal place or the 10th place, so we go after the 10th place, cut it off. That's a 7, so we round up, so that's 2.5. 5.687524, going to the 10th place, cutting it off. All right, that's an 8 afterwards, so we round up, so that makes it 5.7. Next one, go to the 10th place, cut it off. There's a 5 afterwards, so we're going to round up again. 7.6. All right, and then this last one here, going over through the 10th place and then cutting it off. All right, there's a 3, so we round down. 8.2 is what we end up with. This next set is very similar, except now we're talking about things that are rounded to the 100th place instead of the 10th place. So what we do is we go over, get through the 100th place, cut it off. That's a 4 afterwards, so it rounds to 22.49. Next one, go through the 100th place, cut it off. That's an 8 afterwards, so it's 79.26 because an 8 rounds up. Next one, go through the 100th place, cut it off. That's a 0 afterwards, so it runs down 0.03. Next one, 3.4125, go through the hundreds place, cut it off. That's a 2 afterwards, so it rounds down, 3.41. And then the last one here, 41.86632, go through the hundreds place, cut it off. That's a 6, so it's going to round up, so it ends up being 41.87. All right, now on to the math problems. So for these ones, you have to keep in mind these two rules, okay? So with the addition-subtraction rule, we're counting decimal places. With multiplication-division rule, we're counting significant figures. These first ones are all addition-subtraction rules, so we'll be looking at the decimal places. For number 1, this one goes up to the thousandths place, and then this number is to the tenths place, this is to the hundredths, and this is to the tenths. All of that, we look at the different levels of precision through all of those, and the lowest level of precision is going out to the tenths place. Okay? If that's the case, what our calculator would spit out would be something like 26.29. But we need to round this to the least precise level of precision, which we said was the tenths place. So just like we were doing before, we take it over, we round it up here at the tenths place. It rounds up because it's a 9 after there, so it really ends up being 26.3. This next one is a bit trickier. All right, this goes out to the tenths place. This one goes out to the hundredths place. Now this next one, you have to think about your significant figures. Even though we don't think sigfigs really for addition subtraction all that much, it still matters in terms of like scientific numbers and what the number 1200 communicates. When we write 1200 like this, what we're saying is 1200 plus or minus 100. All right, that's our degree of confidence in this number. Those last two zeros there are just placeholders. If we were saying that we knew it to be exactly 1200, we would write 1200 point, all right? And that would say 1200 plus or minus 1. But this is the one, the way it's written now is the one where we only know what plus or minus 100. So the last known digit in this number is actually this 2, all right? So this one goes out to the hundreds place. So we have tenths, hundredths, and then hundreds for that. And the least precise of those is, of course, the hundreds place. So you put it into your calculator and you get 1203.22. But now we need to round this to the hundreds place because that was the least precise out of the three things that we had added together. All right, rounding it here at the hundreds place, it would round down, so you end up with 1200. This looks weird to some people because it seems like you added some things to 1200 and then you got 1200 back out as your answer. Well, here's what's going on. The 1200 was so imprecise that these two small numbers didn't really even make a difference because we knew this 1200 plus or minus 100, remember? And then when we say plus or minus 100 here for this number, 1.62 and 1.6, those don't really factor in when we're looking at uncertainty on the level of plus or minus 100. So we end up just getting the same number back out again. I want to take a second to talk about units, actually. I didn't mention it in the last one. That was all centimeters there. When you're adding or subtracting, all the units need to match with one another, and you just get centimeters in the end. So imagine you're taking a whole bunch of sticks that are different lengths, and you're adding those lengths together. We get one long final length in the end. Problem number 2 was in meters, so that ends up with meters in the end. Problem 3 is a subtraction problem. So we're looking at decimal places again. This one goes out to the thousandths place. This one goes out to the tenths place. So our answer needs to go out to the tenths place. When you put this in your calculator, you should get 0.464. Now, we need to round this to the tenths place, all right? This one out to the thousandths, this one out to the tenths, so our answer goes out to the tenths. We round it here at the tenths place, and it should round up, because there's a 6 after the 4, all right? Rounding that up to the nearest tenth, then we get 0.5. This was grams and grams, and because it's addition subtraction, we just keep the same units, so it's grams at the end. The next one is a subtraction problem again, so again we're looking at decimal places. This one goes out to the 10,000ths place. This one goes out to the tenths place. The tenths place is obviously less precise, so our answer should go out to the tenths place. When you put it into your calculator, you get 4.4168, but we need to round this to the nearest tenth, so we cut it off here. That's a 1 after there, so it's going to round down, so we end up with just 4.4 in the end. And it's meters here, and that's what we get. All right, number 5 is a little bit strange because it's an addition-subtraction problem. So you think, okay, you could add these two numbers together, but the units really make things confusing. To put this in the United States system so that you might understand it a little bit more clearly, imagine if someone told you that you had 2 pounds of something, and then they asked you, what would you get if you took 5 inches and you added it to those 2 pounds? All right? Those things don't really go together. You can't add inches and pounds together. It doesn't make any logical sense. And so this problem we threw in here just to show you that the units have to match when you're talking about addition subtraction. And because they don't match, you can't really add them together. So this one is sort of nonsense. You can't add two things together if their units don't match. Problem number 6. This is a multiplication problem now, so we're using the multiplication division rule. In the multiplication division rule, you count the number of significant figures, not the decimal places. So now we're thinking sigfigs, which means we have to figure out which things are just placeholders, which ones are those zeros that don't matter, and which things do matter. So we count here. This number has 3 significant figures. There are no zeros in there. And this one has 2 significant figures. There are also no zeros in there. So if we have 3 significant figures and 2 significant figures, we have to go with the smaller number. Our answer will have 2 significant figures. When you put this into the calculator, you get 3.013. But we have to round that so it has only 2 significant figures. We start here at the left and we go over. Okay, the 3 is significant. And then this 0 here would be a trailing 0 with a decimal point, so that's significant too. So we cut it off right there, and we end up with 3.0. It would round down because that's a 1 after it. Now on units for this, it's a little bit different. Because we're not adding things together now, we're multiplying them. And so you have to think centimeters times centimeters. What would that give you? And it works just like x is in an equation. In algebra class, if you take x and you multiply it by x, you get x squared. In science, if you take centimeters and you multiply them by centimeters, you get centimeters squared. So that's how that works. Number 7 is another multiplication problem, so we're counting sigfigs. All of these count because they're not zeros, so that one has 5. Here, this is a sandwich 0, so that one is significant, so we do count it. So the second number has 4 sigfigs. All right. If we have 5 in the first number and 4 in the second number, we go with the smaller one, which is 4. You put this in your calculator, and you get 35.7307821. It would go on and on, I think. We don't need to go any further, though, because we're going to round this to 4 significant figures. So what we do, we start here on the left. There's 1 sigfig, 2, 3, 4, and then we cut it off here. That's a 0 afterwards, so it's going to round down. 35.73. All right, now we need to think units here. It's meters times meters, so that's going to give us meters squared. Problem number 8. It's a division problem, so we count the sigfigs. This one, that's a sandwich 0, so it counts. So that's 3 sigfigs. 7.41, none of those are zeros, so they all count. So that's 3 sigfigs. So our answer should have 3 sigfigs. You put this in the calculator, you get 2.72605, etc., etc., etc. Okay, what we're going to do is cut this off at 3 sigfigs. So we bring it over. That's 3 sigfigs. We cut it off here. All right, that's a 6 afterwards, so we're going to round it up. So it ends up being 2.73. All right, and then it's centimeters divided by seconds. In science, the way that that works is that divided by becomes a per. So we have centimeters per second. All right, centimeters divided by seconds is another way of reading that. Number 9 here is another division problem. We have to count sigfigs then. This one, those are all sandwich zeros, so they count. So that one has 5 sigfigs. This one again, all of these are sandwich zeros, so they count. That has 1, 2, 3, 4, 5, 6, 7, 8 sig figs. All right. Comparing 5 sig figs to 8 sig figs, 5 is smaller, so our answer should have 5. You put that in your calculator, you get 3.077707574. But we need to round this so that it is 5 sig figs. Going over 1, 2, 3, 4, 5. We're going to cut it off here. That's a 7 after that, so it's going to round up. So it would round up to 3.0771, and then that has 5 sig figs. Grams divided by grams, just like x divided by x, it's like 1, or we don't have to write it, because grams divided by grams becomes unitless. So this one doesn't have units on it. Then for this last problem, we have 350 pounds divided by 10 inches squared. 350, this is a trailing zero, no decimal point, so that one doesn't count. So we have 2 sig figs on this number. All right, for 10, this is a trailing zero, no decimal point, so that one doesn't count. So we have just 1 sig fig on this number, which means our answer should have 1 sig fig. All right, we put this in our calculator. 350 divided by 10, you get 35. The problem is 35 has 2 sig figs, so we have to round it just like we would any other number. We go and we cut it off here. That's a 5, so it's going to round up. So 35 is going to round up to 40. All right, and then pounds divided by inches squared gives you pounds per square inch. All right, I know that wasn't a ton of problems in terms of how complicated this material is. Please let me know if you have any questions over significant figures. For this quiz and the test that's over this, I'm going to make sure that you really know these, meaning I'm going to require you to retake it if you don't get it right. So it's best to learn it now, because I'm just going to keep on hitting you with it until you learn it. So, make sure to come in and talk with me if you're confused, or whatever we need to do to make sure that you understand sig figs.